Our energy management will radically change over the coming decades. In pursuit of a sustainable energy supply, we'll need to become much cleverer in the way we'll use our energy in future. Among other things, this requires that the present electricity grid will become a smart grid. Liander has taken the first step in this direction. Liander has equipped important junctions in the network, the substations, with a digital control system. An innovative and ambitious project with which Liander leads the international playing field. A smart network responds to two important developments. First and foremost, our energy needs will increase substantially. Electric vehicles, heat pumps, and more electrical equipment require more electricity. As such, increased capacity of the electricity grid is required. The second development is that end users will start producing sustainable energy via distributed energy resources. For example, with solar collectors, wind turbines, bioenergy, or micro-cogeneration. In a nutshell, this means an increased demand for energy combined with two-way traffic on the grid. Let's take a look at how a smart network will look like in practice from the user's perspective. Since it's very windy where the Joneses live, the wind turbines in their district supply a lot of energy. Thus, the local grid doesn't take any energy from the large power station, but from its own turbines. However, elsewhere in the province, there's not a breath of wind where Laura Baker lives. And because it's a cloudy day, the solar cells are supplying little energy. Computers within the smart network now monitor exactly the needs of Laura and her neighborhood, and the surplus in other parts of the area. The system now will ensure the most economic balancing of both supply and demand, and, if required, prioritize energy from renewable resources. Moreover, Laura can ensure that her electric vehicle is charged while the current price is the lowest, which is mostly in the evening or during the night. In the same way, the use of other appliances, such as the washing machine, dishwasher, etc., can be optimized. And should the energy price at a certain moment be relatively high, the system will, for instance, automatically turn off the freezer for half an hour. Putting a smart network like this into practice entails the following steps. The substations and medium voltage networks are given an intelligent control system. Houses are equipped with a smart meter. An electricity grid with a more flexible structure is put into place. Liander has made a start with these three steps. Let's look at the first step, the implementation of an intelligent control system, the SA sensor system, in the approximately 300 primary substations in Liander's medium voltage network. In these substations, the voltage is converted from high voltage, usually 150 kV, to medium voltage, 10 or 20 kV. The energy comes in at the high voltage installation. This is made up of cables, switches, and a busbar construction. The secondary installation measures, controls, and protects. Its former analog components are now replaced by the digital computer-driven SA sensor system. The SA sensor's measuring modules on the feeding and outgoing 10 kV bays continually measure the voltage and the current. At the same time, the system ensures the safety and operation of the electricity network. Does this mean that the present analog system is no longer reliable? On the contrary, the current system is completely reliable. However, current developments are comparable to the developments in telephony. With a bakelite telephone, you can easily phone for 100 years, but not, for instance, send text messages or use mobile internet. It's true that the present technology of the electricity network is highly reliable, yet it hasn't been designed to smartly respond to the ever-growing demand for energy and for the renewable generation of energy. Moreover, it doesn't offer the flexibility that we will surely need in the future. At this moment, the secondary 10 kV installation in the substations is composed of bulky and expensive analog technology. Scores of large racks and cupboards filled with relays, protection systems, voltage regulators, and countless knobs and terminals. and especially loads and loads of cables. In control rooms, the operation is controlled on panels covered with meters and switches. All this will now be replaced by a few sophisticated electronic components. For the total operation and control, all that is now needed are measuring sensors and a computer with powerful processors with just one single screen. What are the advantages of the SA sensor system? First and foremost, the system continuously measures and monitors the current and voltage. This results in Liander having an overview of the load on and the quality of the electricity network that receives current via the substation. This will become even more important when, in the near future, end users start to generate and distribute their own electricity. Besides this, the system makes remote operation possible. At present, most substation installations are limited regarding remote operation from the control centers in Arnhem and Haarlem. With SA sensor, all installations will operate remotely. Engineers no longer need to be on the road continually, saving both time and money. Moreover, resolving a power failure will now, in a majority of cases, be done quicker, resulting in fewer minutes lost power for the customers. Another advantage is the automatic detection of a fault location. In the event of a power failure, the new system fully automatically localizes the fault in the cable network, within a minute down to the exact location. The engineer has no need to search for a location, he simply drives directly to the correct location. For that matter, a part of the present maintenance will no longer be necessary. SA sensor is a digital system. Part of the maintenance will comprise of adapting software that can be done remotely. The engineer doesn't always have to go to the substation anymore. To top it all, this means that the new system is also extremely cost-saving. The SA sensor system is an important initial step towards a smart network for the sustainable supply of energy. Liander is far ahead with this innovative technology, both in Holland and elsewhere. For the Liander organization, SA sensor also signifies a new system and new knowledge. It will be implemented step by step in continuous consultation with its people and suppliers, using everyone's knowledge and experience. Engineers and installers will be the specialists of the new installation. Equipped with fresh knowledge, they will continue to ensure a guaranteed supply of energy, reliable, affordable, and sustainable.